Let's go ahead with the second example, example 10.5. It is to plot the cam profile for an oscillating cylindrical follower. First, we need to prepare the follower rotation angle phi, doing a cam test from 0 degree to 316 degrees, and leave them in a table. Assume parabolic motion for the follower. The follower rotation angle phi are calculated and given in table 10.7. Because this case is an oscillating follower, the follower motion is a rotation. Therefore, the diff amounts of the follower listed in table 10.7 are rotation angle phi in degree. In this case, we use a 20-degree plotting increments to lay out the cam profile. The follower starts from the derailleur. For 0 degree to 120 degree of cam rotation, the rise occurs for the cam rotation angle from 120 degrees to 200 degrees and have a lift angle of 13 degrees. The follower then derails for 14 degrees of cam rotation from 200 degrees to 214 degrees, and a return occurs from the cam rotation angle from 214 degrees to 316 degrees. First, I draw the base circle with a diameter of 2.5 inch here. The prime circle with a diameter of 4 inch here. And the follower pivot circle with 8 inch here. Their centers coincide with orange here. The example gives the follower's first position. In this position, there is a 0 degree pressure angle at the cam angle 0 degree. So now I draw the follower on CD, a line segment from lower center C to the pivot of the follower D. In the initial position, point C is on the prime circle, and I put a point C on the horizontal axis. Then I plot a vertical line pass through point C and intersect the pivot circle to figure out point D. Now I measure the length of the CD. It is 3.46. Then I draw a line segment AD from the cam rotation axis to the pivot of the follower. I connect the orange and the point D. And to measure the degree between the lines CD and AD, we can see this angle is 13 degrees. We call this angle reference angle y0. Point C is the initial position of the follower, so I draw a circle with a diameter of 1.5 inch for the roller. So the roller will tangent to the base circle at low dwell position. Because the cane rotates in the clockwise direction, the follower has an invert motion in the counterclockwise direction. So I use a circular pattern. To copy two lines, CD and AD, every 20 degrees in the counterclockwise direction. So we will have 18 positions of the follower in the motion during the 360 degrees. Next step, we need to get the roller center position for each follower position. Each line CD is the baseline for the lift angle of the follower. When the follower is to dwell at zero lift angle for the first 120 degrees of cane rotation, the roller centers are on the prime circle. The roller center will coincide with point C, so I draw the roller circle on each point C for the cane angle from 0 degree to 120 degrees. I use copy entity, select this circle, and give its reference point here, and copy to 20 degree here, 14 degree here, 16 degree here, 18 degree here, 100 degree here, and finally 120 degree here. During the rise to the return regions, the follower rotates at an angle given in Table 10.7. So I draw lines with 3.464 inch in length at the angles indicated in Table 10.7 from the corresponding baselines, and the point C of the lines will be the roller centers. So I write a line here at the cane rotation angle is 114 degrees here. And give it the lift angle. (3.75 degrees). This value given in Table 10.7. And then I join a circle here. Its diameter is 1.5 inch. And I give it this length of the CD equal to 3.464 and enter. So I get his During the rise to the return regions, the follower rotates at an angle given in Table 10.7. So I draw lines with 3.464 inch in length at the angles indicated in Table 10.7 from the corresponding baseline. Endpoint C of lines will be the roller centers. Let's see the can angle 114 degrees here. The lift angle is 3.75 degrees. This line is the baseline for the lift angle of the follower. And this point is the pivot of the follower. I join a line from the pivot to here and give this line an angle 3.75 degrees and give it length 3.464. Later I will modify this value. So we know this length, this line is the follower arm, and this point is C. So I draw a circle here and give it diameter 1.5 inch, and to get the position here, let me see 116 degrees here. The lift angle is 15 degrees, so I do the same thing. Draw a line CD here and give it an angle 15 degrees. And later I will give a corrector length 3.464 inches. And here I draw a circle here. Give it diameter 1.5 inch. We continue to do that until can angle 316 degrees. You see the length of the line CD is 3.464 inches, and I draw a circle with a diameter of 1.5 inch at every point C of these lines to get the locus of the roller, like this. So you can see every lift angle is according to the table 10.7. Then, like example 10.3, I will draw a curve tangent to the position of the roller to get the cam profile. I select a spline here and give an initial point here to look for the tangent point here, 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 and this is the right position. A little difficult to find the tangent point, so I just give here. Okay, here and here. Okay, you see, we get the cam profile now. Finally, we need to indicate the pressure angle. I will show you how to get the pressure angle when the cam angle is 116 degrees. The furrows here rotates about the period D. So I draw a line that is perpendicular to the furrow's arm to get the direction of the furrow motion. I let this line and this line perpendicular each other. So I give them a relation perpendicular. So this direction is a furrow motion direction. And then I draw a normal line, pass through the contact point here. Then I measure the angle between this line and this line. We can get a pressure angle is 32 degrees. Today, we talk about how to lay out a cam profile. Two examples are given to plot the cam profile for the radial roller furrow and for the oscillating cylindrical furrow. I hope you can follow the description and practice by yourself. Anyway, see you Wednesday. Bye bye.